Hello everyone. So today again we will discuss one set of CAD 2020 slot 2. Let's directly move to the set. Yes. So the set is 25 colored beads are to be arranged in a grid comprising of 5 rows and 5 columns. Each cell in the grid must contain exactly one bead. Each bead is colored either red, blue or green. That means it's not necessary that I'll be using all the three. I may use exactly one type of beads, or else exactly two types of beads, or else exactly three types of beads. While arranging the beads along any of the 5 rows or along any of the 5 columns, the rules given below are to be followed. Two adjacent beads along the same row or column are always of different color. That means I have to use at least two types of beads here. There is at least one green bead between any two blue beads along the same row or same column, but they have not said vice versa, right? So if I'm using two blue in a particular row or column, I should have at least one green in between. There is at least one blue and at least one green bead between any two red beads along the same row or column. Every unique or else complete arrangement of 25 beads is called a configuration. So now let's say we have a grid available here, and I want to insert these beads here, and I have to follow basically these two rules, right? Rule number 2 and rule number 3. These are the mandatory rules available here. So let's see. Let's make a table here where I'll keep red, blue, green, and let's keep minimum and maximum. Right. So suppose if I'm talking about red here, and I want to maximize the number of reds here. Let's try to find out this thing. If I want to maximize the number of reds, what is the rule for reds here? Here there is at least one blue and at least one green bead between any two red beads along the same row or same column. So if I want to maximize my reds, I should definitely move in the diagonal cells. Say I'll keep a red here, a red bead here, a red and red here. So now I know that there should be at least one blue and at least one green bead between any two red beads. So the minimum possibility is I'll have one red at this point, I'll have one red at this point, right? Similarly, I can say I can move towards this side, so I can have one red at this point and one red at this point. Now this gives you information that I can maximum have 9 red beads possible here, right? Now why it's happening? Because see, my condition is if I'm choosing if I'm taking condition where I'm choosing two colors, then I have only one option, that I have to use a combination of blue as well as green. If I'm using 3 colors, that means I have to use blue, green and red, right? So if I want to maximize red, I have to use all the 3 colors here, and I have a rule available for that here. Now if this is the condition, I want to minimize my number of reds. What will the minimum number of reds possible here? My minimum number of reds possible will be, I'll be using exactly 2 colors here, right? That will be the case when I'm using the minimum number of reds here. So that means the minimum numbers of reds I can use is nothing but 0. This is the basic thing which we can identify from the given information here. So let's try to identify something else also. Here suppose I am minimizing my number of reds here. That means I'll be definitely maximizing either my blue or else green. So now here I'll take the case of maxima where I can have maximum 9 reds available here. If I'll take the case of minima where I'll have 0 reds available, that means I should have a combination where I'm using green and blue. Suppose I'm using green and blue here, and I'm trying to maximize green. Assuming I'm trying to maximize green here, so I'll be using green and blue only. So I'll be using green here, green here, green here. Alright, similarly, next possibility is I can have green here, here, here. Then again at these points I can have greens. Right, similarly I can have green at this point, green at this point, then green at this point, and green at this point. Right, so now I can identify if I want to maximize the number of greens, my number of greens maximum possible will be nothing but 13 in this case. Right, so if 13 greens are there, that means the number of blues in this case will be 12. But is it the minimum possibility? We are not sure about this. Right, so now because see, my condition is I cannot say that 12 is the minimum in this case, because I know that I'm using red as a minimum possibility in this. I can say blue will be only minimum when I'll have red is maximum as well as green is also maximum possible in a particular format. Right, similarly I can say suppose I want to maximize blue here. Same logic is applicable in this case. Right, suppose I want to maximize blue here, so I'll be using only two colors, blue and green here. So I'll use blue here, blue, blue, then again blue at this point, blue at this point, and I'll be using blues at these points only. Right, so I can have maximum 13 blues possible. Right, so I have identified that maximum I can have 13 greens possible, 13 blues possible, maximum 9 red is possible. But I want to minimize, suppose I want to minimize my number of blues, that means I have to maximize my number of reds as well as the number of greens. So I'll be dealing with this situation here, because I have to maximize my number of reds in this case. So here I'll try to maximize my number of reds, and I want to minimize my number of blue in this case. So let's try to maximize my number of greens. So if I'll try to maximize my number of greens here, I can use greens at these points. Suppose I'm using green here, green here, green here, green here. Similarly I'll use suppose green here, green here, green here, green here. I'll be using greens at these points. Right, and between two reds I should have at least one green and at least one blue. Right, so here in this case, here I can use blue, here I can use blue, here I can use blue, 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 blue. But I want to minimize the blues, that means I'll put green at this point as well as green at this point. Now this will definitely satisfy my condition. So now I can put blue here, blue here, blue here, similarly blue, blue, and blue. So it satisfies my criteria. Between two reds I should have green, blue, at least one green, at least one blue. Between two reds I should have green, blue. Between two reds I can have green, blue. Between two reds I can have green, blue. Between two reds I can have green, blue. So every time it's satisfying the criteria. Right, so that's the case when I'm trying to minimize my number of greens, number of blues in this case. Now I can identify I'll have 6 blues available here. Right, but if I want to minimize my number of greens, let's see, if I want to minimize my number of greens in this case, whether it's possible or not. Let's try to identify this. So I'll try to maximize my number of reds as well as the number of blues here. So if I want to maximize my number of reds, I should start with reds first. So I'll keep red here, red. Let's take this basic criteria, then red here, red here, then again red at this point and red at this point. I want to maximize my number of blues now in this case, right? So let's check whether I will be able to maximize this or not. So I'll be keeping blues at this point, but I'll have to follow some rules also, right? Then I'll put some blues here. I have to check whether it satisfies the criteria or not. Now the problem in this case is, suppose if I'll take this condition, there will be some rules which will be violated here. So I'll put one blue at this point, one blue at this point, right? So let's see. So if I want to insert greens here, what are my possibilities here? So what I can do here is, it's already given that at least one green bead between any two blue beads along the same row and same column, right? So now suppose if we'll take this one, I'll insert a green here, I'll insert a green here. So I can insert a green here, right? But I cannot insert a green here because in this case this rule will be violated. So what can be done here, I'll be changing this and I'll put the blue at this point and I'll put a green at this point here. Right, so let's put a green at this point and blue at this point. Right, now here if we'll consider this case, then I'll insert a green here. I'll just mark green with this. So I'll insert a green here which will satisfy this condition, but the blue cannot be at this point. Suppose a blue will be here, then I should have if blue is at this point, that means here I should have a green, which is not possible here. So I can do one thing, I can insert a blue here so that I can insert a green at this point. I'll just mark green with this, right? Then I can have green at this point, right? Let's keep green at this point because I have two blues available at these points. Remember, I have to maximize my blues also, right? So now I will remove this one and I'll insert a green at this point, right? A green at this point. So let's see whether it satisfies the condition or not. Between two blues I have one green available, right? But the problem here is this is not possible. So I'll remove this one. I'll have to use a green at this point here, right? So now one green is at this point here. Between two blues I have a green, between two blues I have a green, between two blues I have a green, right? So now if we'll check how many greens are available, if we'll consider the cases here, I have 1 2 3 4 5 6 7 8. Now in this case possibly I can have 8 greens, right? So this is my possibility. We'll have to find out the other relations also in this case, right? So these are the basic informations we have tried to gather so we can be sure of a red maximum, blue maximum, green maximum, blue minimum, red minimum, almost green minimum here, right? There is no other way out to find out the green minimum in this case. So these are my basic informations available here. So let's move to the questions now. The total number of possible configuration using beads of only 2 colors is. So now that thing which we have already seen earlier in the previous example, if I'm using 2, that means I have to use green and blue here. So what are my possibilities? The first possibility is, suppose I'll put blue here, blue here, blue here, then blue, 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 then again blue, blue and blue. That means for the remaining places I'll have to use greens, right? So for the remaining places I have to use greens. This will be my first configuration possible, and the second will be nothing but vice versa. Instead of blue, now I'll use green at this point, right? And instead of green I'll be using blue, right? So I can change the values here. So that represents I can have 2 types of configurations possible here, right? So I can say I'll have 2 types of configuration possible, right? Similarly, what is the maximum possible number of red beads that can appear in any configuration, which we have already seen? The answer was nothing but 9, right? Or else let's try to identify. I have used red here, red, 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 then again red was here, red was here, red was supposed to be at this point, and red was supposed to be at this point, right? This we have already identified. And then the next one, what is the minimum number of blue beads in any configuration? That also we have identified. There were 6. So what were the condition in that? So we have already used, I have tried to maximize the greens here. So to maximize the greens, I inserted greens at these points, and the remaining places were occupied by blues, right? Next one. Now 2 red beads have been placed in second row and third column. So now the red beads are in the second row and third column. So these are my rows available. Second row and third column red is available at this point, and third row and second column, third row and second column. How many more red beads can be placed so as to maximize the number of red beads used in the configuration? I want to maximize my number of reds, so I'll have to move in a similar fashion. I'll have to move in the diagonal format. Then I'll take the gap of 2's. So that means now 1 red is supposed to be at this point. Then I'll take the gap as 2. 1 red will be at this point. Then red will be at this point. Then red will be at this point. So altogether, if you'll see, I have altogether 8 reds possible in this case, right? 8 reds are possible, and they have asked how many more. They have asked how many more reds. So definitely 6 more reds are required, because these 2 are already there, right? So these 2 are already there. That's all for today. Thanks for joining us.